Welcome to the Data Playbook podcast. It's a podcast for data leaders where we aim to build a playbook for them to enable more people with data. We do that through a series of interviews with other data leaders, data experts, and data practitioners. And today I have with me someone from Dataminded, Jelena. Welcome to the show.
Thank you for inviting me.
My pleasure. Jelena, before we start diving into the topic, can you introduce yourself to the audience and talk a bit about your background?
Yeah, sure. So my name is Jelena Grujic. I originally come from Serbia, where I study physics. And since then, most people will say what I do is not physics, but I will consider myself a physicist until the day I die. So I'm a physicist. That's how it goes. And another thing which I did there, I was part of this CERN project. So we had actually a big cluster, and we were talking early 2000s, okay? So cloud was not a thing, especially the industrial cloud, But we had this like 2000 cluster of 2000 processors in our room. And since we were in science, we had to manage everything ourselves. So I do remember how things started, like almost 25 years ago. And I can see clearly how they are developing now. Which might become important later when we discuss about how things change and how the rules we apply and should also change, After that, I did my PhD in Spain, doing data science before data science was also a thing. So analyze data from behavioral experiments, analyze complex systems. I continued doing that at Imperial College in London, doing a postdoc. And then in 2014, I came to Belgium, and I was part of an AI lab, which was kind of just, I randomly ended up there because somebody I wanted to work with was there. And in the beginning, I would tell people I work in AI lab, and everybody would be super bored. And then AlphaGo happened.
Wow.
And suddenly I was in the right place, in the right time, surrounded by people who's been doing machine learning and AI since before it was cool. And then I learned a lot of things from machine learning and AI, and used it to analyze data science. And at some point, I start seeing academia as like a pyramid scheme. And so I was like, okay, and like this industry is actually getting interesting. There's like so much data there, so let's do that. And I start applying randomly because I had no idea about my market value. And then I very quickly realized I do have some market value. Nowadays, I know, if I see a CV with AI Lab and Imperial College, I would definitely invite that person for interview. But back then, I didn't understand. And one of the companies I randomly applied was Dataminded. And then I realized it's data engineering. This is not what I want to do. I want to do data science. However, I like the company. And I start thinking like, hey, this data engineering thing, it's super important now, because this was like, at the moment, there was the most famous quote is like only 12% of all projects go into production, And like, even if I don't want to do this later, it's going to be super useful to learn it for now.
Yeah.
And, if I don't like it, I just leave the company in a
small detail.
So 2 years later, after working very data engineering tasks, like I was proper data engineer, I start missing data. And I was like, oh, actually, I would, I actually really want to do more like data science and use all my data engineering knowledge. But then I found a new client through Dataminded. And now with my client, I do more data science work, but we also do all our own data engineering. So, I see things from the both sides, like in my heart, I'm a data scientist, but I also worked as a data engineer, and now we're in charge to do everything. So I feel like both, and I feel like I understand both sides.
Yeah. So the topic of today is very closely linked to your history. Actually, it's about breaking the wall between data science and data engineering, right? Why is it important that we break that wall?
So because it annoys me. It makes my life difficult, But why I wanted to talk about this is basically, I heard there was always this discussion like data science is data engineering or data science is not data engineering. And I heard that so many times, it always annoys me. The arguments people present they don't annoy me. I actually agree with 90% of what either side would say, But the existence of this discussion was just like something which boiled my blood. And after a while, I realized this is because this is just the symptom of the great divide between data engineers and data scientists. And I mean data engineer and data scientist, not data engineer and software engineer, okay? Because most data engineers come from software engineering background, while data scientists come more from like science or data analytics background. And people who claim data engineering, software engineering are mostly going to be data engineers. And people who say, no, it's actually not software engineering are going to be data scientists.
Okay. Well, we're going to dive into that conflict or in that wall, if you will, that divide with some very concrete examples, right? And maybe a first point of discussion that usually goes on between engineers and scientists is the use or the non-use of unit testing.
Yeah, this is always everywhere I was, there was always a conflict about unit testing. And by unit testing, I mean also, I don't mean the package unit test or, it includes any kind of test which will not test data. And this shows also what's kind of wrong with it, if I can say that. But, let me explain. Let's see, we have a data engineer. How is data engineer going to develop their code? They're going to say, like, okay, what are the requirements of my code? And then they're going to sit and they're going to think about, okay, so what are the requirements? What are my side cases? And then they're going to write unit tests, usually even before they write their functions, and because they have to document their requirements, the outliers and everything like that, And then they're going to write unit tests because they need automatic way to test the code, like you don't want to write the function and manually put stuff. You want something to go fast and automatic. And then they're going to write their function and they're going to run their unit test on the function until there are no bugs, everything works, they're done, okay? Yeah. Data scientists, how they're going to do that? They're not going to think about the requirements because their requirements are in the data in front of them. So they're first going to sit and analyze the data. This is their requirements. Then they can immediately write the function because they can easily test if the function works just by running it across the data. So they don't have this necessity to write unit tests to make things automatic, And then they're going to write their function and they're going to test it on their data. And then when it's work, they're done. And they're going to give that to data engineer, and data engineer head is going to explode. Okay? And why is data engineer head going to explode? Well, they need to put this in production. This is just not feasible. This needs to run for days, months, years. You need to change this function many times. There's going to be many additions. You just can't go and manually test the code all the time, even if you would know how. And the person who is going to add something in a year, they're probably not going to understand how to exactly manually test your code, So this is just not feasible. But this is not what they're going to tell data scientists. What they're going to tell data scientists is going to be like, oh, you silly data scientist, you don't know any coding practices. You should write unit tests, okay? So best case scenario, data scientist complies and they start running unit tests. But they don't really know how to write unit tests. So they're going to write some super complicated, huge samples of data. They're going to test every single function. And this is so tedious and it's exhausting, And after they finish this, they're going to run that against data and there's going to be some data quality issue and the code will break. So they're going to say, hey, this is difficult and it's also not useful, And data engineer will say, oh, come on, it's not so difficult, And at this point, the wall is bigger, And they just stop talking to each other. Data scientists will not run any unit tests and will not comply anymore. Data engineer will be annoyed because we'll have to put in production something which doesn't have any of them. And, we have a super big problem. And I see this all the time. All the time in many clients, many companies, there is this huge divide about unit testing.
Okay. And well, I can confirm the stories you share. I've seen them as well. But I think both sides of the argument are right? So for a data scientist, it is important to work with the data and find insights in the data and build your logic based on what you find there. But for a data engineer, and I've been there myself, it is super frustrating to get these huge files from data scientists with zero tests. It's like, yeah, I know this will not run 2 days in production, right? So how do you bridge that gap?
So there are like some things data scientists needs to learn from this story and some things data engineer needs. First thing, data scientists needs to understand this code needs to run in production.
Yeah.
Okay. And second thing, they need to understand there is a skill in writing unit tests. Okay. So you need to learn how to do it. When you do it, it's still going to be tedious, but it's going to be much less tedious and way more useful. The data engineer needs to understand that manual testing scientists do, it's not like super easy thing, like it's not just like, run it and doesn't test anything, there's usually a lot of there and they will test the code at this moment of time, they will make sure that this code works. However, the problem they're facing with is first, unit test will not test data. Okay. So, and data is big part of data engineering. And second, the point is not in unit testing. The point is automatic testing.
And what's the difference?
Unit testing is just one type of automatic testing. Okay. There are more what you can do to test not just your code, but also your data. Okay. And this is what bothers data engineers. And the only solution they know is unit testing. But there are more solutions, to this. And those solutions are, and you can see, for example, in dbt, these are already implied. And maybe there are some other tools which are going this way. But in dbt, for example, you have this like test on data, because garbage in, garbage out. So first, what you want to do, you want to write tests which are going to test the input coming. You want to check there are nulls. You want to check if things are unique, you want to check if the table is empty. Okay, this sounds like trivial, but
no.
So important. Like always write the test if the table is empty. Always. Okay, it happens way too often. But you also want to test some more, not so trivial stuff. Like, is your distribution Gaussian? Do you have outliers? Like whatever kind of makes sense for a data. And then once you have that, then you can have your functions. You want to write what we call smoke test or singular test in dbt, that would be. And that's basically test on data which is coming out. Okay, so now when you transform your data, you probably also want to check, did you introduce some nulls? Did you make duplicates? But also you want to write tests which are going to compare this output with input. So for example, you probably have some checksums you want to do, before, and you want to make before and after. And these tests I find the most useful. They can be a bit tricky to write because I can't tell you, write this and that list and it's going to work. It really depends on your project, And the best way to write it is like you start with your manual testing and then you just notice what kind of things you are looking at, like when I'm checking if this is working, what are the things I'm making sure kind of is happening, and then take those, and you write them, and it can be things, for example, time interval can be negative, sum of revenue has to stay the same. You can't make money out of thin air or destroy money out of thin air. That would not be make very happy customers, So these are kind of things you can do. But then be careful. Don't write all of them, for a couple of reasons. First, you're just going to waste time. Second, unlike unit tests, this run on data. So it can take a long time to do. So you have to be wise in picking the ones which are not going to kill your calculation time. So don't do over kind of do that,
And then when you do data quality tests, you do those smoke tests. What's your advice? Don't do unit tests at all?
No, actually, of course not.
Okay.
We still need unit tests. And there are a couple of reasons I like unit tests, to have unit tests in my code. First is actually documenting your code. Sometimes it's not super obvious what the function does, but if you have wisely written, very small unit test, it can be immediately obvious what it does if you're looking at unit tests. Second thing is documenting data quality issues. So if you encounter some problems, you will probably have to write a function which deals with that and might not be clear. So again, it's kind of helping explain your function, but it also literally documents data quality issue you encountered in your thing. And the third thing, it's not going to test your data, but it still tests your code. Okay. So it still does the original function, which was written to do. And you still need that. Okay. So you want to make sure your code is maintainable, and in 2 years, when you need to change this function, you want to make sure that you didn't mess up something and that it still does what it's supposed to do originally.
And then the opposite, if you're also seeing unit tests that you say like these had no value, just delete them.
I don't know if I would delete them. Depends how many there are. If they're really, maybe put a module for the ones you keep them there. It's somebody did there, but I would definitely have a conversation with people writing them to explain to them that this is not necessary. This is killing their productivity, and you should just not do this in the future.
Can you give an example of that? Or when is it not useful to write a unit test?
If you have a function which just does a filter and join, like this function, PySpark already tested them. Okay, so you don't need to write unit test which does filter and join. Most of the times, if you want a simple roles never work. But one of the simple roles is like if you have a window function, for example, then probably you should write unit test, like then the logic becomes a bit more elaborated. Another way to do it, like you should always peer review your code, and then you send it. And if the person is like, I don't understand this function, write a unit test, or even they misunderstand your function. They think it's wrong for something that happened to me. For example, somebody was like, oh, this function is wrong, but actually they just didn't understand what it is. Then I write a unit test and I'm like, hey, this is and then they're like, okay, now it makes sense,
But it's an important distinction you make, because I've also seen that in practice where people test standard library logic. Like the PySpark filter function will work, and if it doesn't work, you're not going to fix it. I mean, and the same with a window function will work. So you're not testing if a window function works, you're testing if you've applied the right logic to apply that window function.
Yeah, that's why I say window, this is a simple rule, which it's like when I say there is a window function, then there is usually more elaborated logic, but you will have function which is just window function, and then probably you don't need to unit test.
Another heated debate in data engineers versus data science, and we've done whole webinars on this, is the whole notebook versus code base.
Yeah.
So how do you look at that?
Yeah, so I hear data engineers always going around and saying, look, notebooks, they're so lame, and check, yeah. And that really needs to stop, just stop, okay? Going there and doing that just tells me that you have zero idea what does it mean to analyze data, okay? If you actually analyze data, you really need this just fast interaction your notebook offers you, And I'm telling you this as somebody who coded like for 20 years before notebooks were created, okay? Mm-hmm. And when they were created at the beginning, I actually didn't use them because I was just not used to them, But later you're like, hey, this is very convenient, like just seeing my data in a very clear way instead of like 5 lines, being able to just quickly visualize stuff and check this distribution and scatter plot without, spending 5 million years to just kind of write this function in something nicely, it's saving the picture, then find, like this really makes you more productive, and notebooks are just very, very good for this, okay? So please leave data scientists use their notebooks. If you need to look at data, try it yourself. It's actually very cool. However, what I want to tell data scientists, notebooks, very good at the exploration, but once you have to scroll and scroll and scroll, it's time to move to code base, okay? It's time to organize your code, have different modules, and this is going to make your code way more readable, easier to understand. So early phases, use notebook, but as soon as you wrap something up, you write a nice function, put it in a model somewhere, and you can just call this function in your notebook if you still want to have this notebook, but put most of the bulk somewhere behind. You don't have to see it there.
So your recommendation is start with notebooks, but if you see things become too complex or too long in notebooks, move them to a code base with a IDE and with modules and some structure in there, right?
Yeah.
Because that is the flip side. I do agree with you that data engineers, when they rant about notebooks, they don't understand the problem that data scientists are solving. At the same time, I've also seen plenty of very ugly notebooks in production. And you also don't want to end up there, right? No. So I wonder, both extremes are bad. Like, you cannot forbid notebooks. You also cannot just put them in production as is.
Yeah.
But then what do you do in practice?
Yeah. So at my clients, what we do in production, we start with notebooks, and the notebooks, and then we move stuff to the code base, and the final product is actually going to be very short notebooks where you read all the data, you call the function from some code base which is somewhere hidden. And then you write all the data.
Yeah.
And our pipeline will have this kind of notebooks in chain or what kind of structure they need to have. But this way you make it very clear what is the input data for your thing and what is the output of this kind of module. So each notebook is kind of the main of the data. So and this also, like, if suddenly you need to check something back into notebook, it's kind of, you have easy way to just kind of put it back and display it, but it keeps it clean for production.
Yeah. So you do the reading and writing of files in a notebook, but then all the logic is in code, in production.
Yeah. In production.
In production.
Yeah.
Okay, well, that makes sense. When we're talking about production, another heated debate I see a lot is you shouldn't be allowed to see production data when you're doing your data science. So use test data.
No.
How do you deal with that as a data scientist?
Because this is a big one and in a way very controversial. And I actually kind of Googled and I was like, hey, should I put and you get huge no. And if you go to data architects, another huge no. Huh? And I even asked ChatGPT and I got huge no, like never ever do that. And the main reason is security.
Yeah.
So why is this? So you don't want your data leaking, especially if you're a bank, if you're a hospital, these are very private data. You don't want your data leaking. Mm-hmm. So what do? You have one production system and there only a couple of people have access, and then you have the test system where everybody has access, So, but there, because everybody has access, you can't put like the sensitive data there.
No.
So what they normally do, there are three main solutions: anonymized data, sample data, and synthetic data. Okay.
Yeah.
So none of them are very good solution. Okay, let's go over them. Anonymized data. There's a very famous case by a Harvard professor. What she did, there was some insurance company put online anonymized data, and she took this data, crossed it with some other openly available data, and she managed to identify 82% of people.
How did she do that?
So she just used date of birth, gender, and a zip code.
Yeah.
So those three information, 82% of people. So which tells you, even when you anonymize your data, just don't put them online, okay? So that's not a good idea. But you can say, but we can remove the date of birth, And we can remove gender, and we can remove the zip code. But I can't do analysis about gender biases with data like that.
Yeah.
I can't do many health research about that because age is very important in this data. So the more data you remove, the more information you move,
Yeah.
And it's still questionable, can you put them just online?
Yeah.
So let's not put sensitive data, even if they're anonymized, you should never put them online. Okay. And if you can't give it to me, even if they're anonymized, then what's the use of them for me? Okay. It can be very extreme cases when you're talking about very sensitive data, like medical data or bank data. You can anonymize it, but anonymize it specifically to my project. So make sure that you remove only the information I don't need and keep all the information I need. And you still give it to one person, okay?
Yeah.
Not everybody, not online. You anonymize it for a specific project, give it to this person for the duration of time they need it, and then take away this permission, okay? So this is the best way to deal with that. Second thing, synthetic data. So we had a Data Bears talk recently about somebody who was doing synthetic data. It's so difficult to make good synthetic data. There's like so many things you need to recreate from this synthetic data, you know? It's not just I put random names, you know? Like what if somebody wants to research about what are the most popular names in this country, you know? Like it's not about, you know, you need to make sure the distributions are fine, that so many things. And even when somebody then start making research, they don't know what this person put attention to and what didn't. So who is going to make this synthetic data? The best person to make this synthetic data is going to be the person who is doing the project. So why then just give them access to the data?
Yeah.
You know, like you just kill a lot of work. Just give. Again, keep it restricted. Just this one person, not whole world, you know? And finally, it's like sample data. That's used a lot. And the problem with sample data, again, how do we make a sample? You know, I can just if I take a random rows, I can kill a lot of information. Like, let's say if each row is like a station of the train coming, and I take random rows, and suddenly my train loses all the stops. You know, that's not going to work. Okay.
Yeah.
So you will probably need to say, okay, I'm going to pick a couple of trains, you know. For other things, you know, there's different ways you can sample your data. Again, depends on your project, you know. And anyway you sample your data, there's always going to be data quality issues which are not going to be in the sample. And then when you run this in production, it's going to fail.
Yeah.
Because the data quality issues are just not there. So none of this.
But you are making our lives difficult because you say, I don't want synthetic data, I don't want sample data, I don't want anonymized data. But then what do you want?
So what I want, we should abandon this old notion that we could have only one production environment and one test environment, okay? Nowadays, we are very capable to make a lot of small environments all around, actually. Data mesh is very popular nowadays, and the policies are usually each team has their own data, and each team then can have their own production environment and their own test environment, and it's so much easier now to organize this. There's no reason for your test environment to be less secure than production environment. Like absolutely no reason. You can just make it exactly as secure as in your production environment. Otherwise, you are risking that people are actually going to start debugging in production environment, you know, and you don't want that. You know, if your people are start doing shady stuff, your system is not designed properly. Okay. So let's stop with this old-fashioned notions of one production, one test, and use a lot of tools we have. You know, we have IAMs, roles, you know, many different ways to do this. And again, give it to people purpose space, you know, just the person who needs it, just as long as they're needed, you know. And if it's necessary, you can do some kind of anonymization if it's very, very sensitive data. But again, project-based, like make sure that there's still information there which is necessary for this project.
Yeah.
Okay?
Yeah.
So this is...
And do you see, because I agree with you that there's two angles to your solution. One, there's a technology angle where you say, look, we're not in this on-prem system anymore. We have one prod and one UAT and one dev. So you can have like 100 prod environments if you want, or 100 test environments. You can just create on demand and you can test in a prod-like environment. But the other angle that you mentioned, the security purpose-based access control. In practice, let's take your current client as an example. Did you find a lot of When you proposed this way of working, did you have a lot of objections against that way of working, and how did you overcome? What were those objections?
Yeah, absolutely. There was a lot of objections at the beginning. Like first they were looking at me like I'm crazy. Like, what are you thinking? Like, I'm not doing this. And the first solution was they just copied all the data from production to test.
Oh, I've seen that as well. What's wrong with that? That's a good question.
Well, it kind of half solves my problem because, like, at least I have a data, but it's just wasteful, you know? Like, it's completely wasteful to copy because it doesn't help security at all. Yeah. Like, you just have data in a test environment, which maybe you didn't secure properly, you know? So you're just kind of making security worse, okay? And my problem with accessing data is mostly solved, but still there are going to be situations, for example, we have very long projects, which in production takes like 2 weeks to do the data. And we have the smoke test, which sometimes will give us alert that there is a new data quality issue. So, and they're going to produce the data, which is only in production because it's, of course, you know, and then if I want to solve it, I have to debug in production. Yeah. You don't want people to debug in production. Okay. So if you just give me access, only read, let's make that clear, only read, no write access. There, you don't waste your resources on copying the data. So, which it costs. Like now, you know, there's a lot more talk about how cloud is not so cheap anymore, you know, so you need to make sure that you are not using extra compute to transfer data, you have just double data. Again, there's like a different, normally like my test data, they're going to be code from test environment. But the whole point of test environment is that you can mess up, you know? So somebody down the line is going to mess up. Suddenly my test data is not the same as my production data, you know? No. So you have double work everything. You have, you don't help security at all, like zero. And you still have problem if I create new data in production, which are not going to be on my test, and I need them to figure out what's going on.
Absolutely. And I think I want to add one more thing to it is the engineering overhead. It sounds like a simple thing to just copy production data to a test environment, but I've seen it a few times and there's always things going wrong and firewalls and I forgot to include this table and now that table is out of date and it's out of sync and it's yeah. But
it's also like, I can say like if you ask data architects or you Google whatever, it's going to be a huge no. But if you actually talk to people like data engineers, I'm thinking not even data scientists, but data engineers who work closely with data scientists, they will all tell you this is the best solution, you know? Yeah. And even we had a meeting with Databricks, and Databricks, apparently this is what now they are advising at clients to actually just give read access to in production data and make sure your test environment is secure. It has to be as secure as in production environment because, of course, we don't want data to be leaked.
Yeah, nobody wants that.
Nobody wants that. But also, data scientists, if you know, you can't ask data scientists to give you insight from the data they haven't seen, because insight is just there. It's not in the anonymized data, sample data, synthetic data. It's in the data you need to see.
All right. Another topic that you raised, you're attacking a holy house of software engineering, is which we all learned in university, is object-oriented programming.
Yeah.
What's wrong with that?
No, there's nothing wrong with object-oriented programming. I think in software engineering, it works very well. There is a reason why object-oriented programming is so popular in software engineering. A lot of good reasons, okay? But it doesn't translate so well to data engineering. And one of the biggest reason is mutability or immutability of the data.
What is that?
So mutability basically means that something, so the object can be changed after it was created, okay? So that it means it's mutable. However, what happens when you have big data, usually you have this distributed system to calculate them. So you're going to have half of your table on this, half the table here, half the table, well, thirds actually there. So let's say if I object-orientedly do this, and this is actually mutable, something can change here, but not here.
Yeah.
So this creates a lot of mess, and it can make problems and with calculations, and can make your results problematic, which is, if you want data, this is not something you want. So this is the big reason why object-oriented programming is just not the best solution for analyzing big data. The solution for this is actually just straight functional programming. Okay.
What is that for people who don't know the difference?
So in functional programming, you have, so basically when you do data in data engineering, data science, most of the times you have these transformations. Okay. So you have a table, you transform it, and you get out. So what you do, you write a function, and this function will have argument your data frame and will give you another data frame and you can just chain them one after another. And then this way it's everything is immutable, it can be easily distributed and everything is again, also why in software engineering people like object-oriented programming a lot is because it abstraction, like it kind of abstracts the whole complexity of what's going on, and it can make things way more clean. It's what's going on. However, when you do transformations, you don't want to abstract anything. Like everything is important, like everything about that function is important to me in this transformation. If you abstract something, it can make your transformation less clear, because you just want everything in your face.
But then are you advocating to just write one huge function, do all your transformations in there and then ship it?
No, of course not. So you can write many functions. So each, it's always a good idea to make modules of your code. Like you want to have little pieces of code. Each of these pieces should be separately tested and make sure it works. And once this one works, then you add another piece. This way you have, and I think there's this misconception that you can only do in object-oriented programming, but actually you can easily achieve that with functional programming. You just write multiple functions and then you call them from different part of the code.
All right. Well, that makes a lot of sense. I think especially in data pipelines, I've seen actually a project where the whole ETL process was mutable. It was a complete mess. It was it's not even talking about object-oriented programming, but just it doesn't fit in your head anymore. It's also not about can I parallelize this over multiple machines, but just understanding which process updated which value, right? Well, in functional programming, as you explained so nicely, the nice thing is, okay, you have input data, you have a function, you have output data. And then you have another function of output data, and then you chain that. Yeah. But then there must be cases where object-oriented programming is still okay, right?
Yes. So when we talk about transformations, stay away from object-oriented programming. But there are part of your codes which are not going to be transformation. It's not going to be a big part of your code, but it's going to be there. And the biggest example is like reading and writing files. So often when you read or you write files, there is complexity you want to abstract, especially like you want to make your code easily changeable from test and from between different environments, between different projects and stuff like that. And this is complexity you want to hide, So we normally have this, what we call data handler. So we have some kind of function, which is a class, and we have all the things defined there. So when I use it in my project, I just said, read this file, and all the complexity about like, is this in test? Is this in production? Is this project? Is it that project? Should we use Parquet files or Delta functions or whatever, That's already in that. So if we want to change, which we did, for example, we used to use Parquet files, now we use Delta tables. I don't have to change everything. I just change this one, class I have, and everything applies across the project. So there are uses for object-oriented programming. Reading and writing is definitely one of them. There might be more. So I'm not saying like just throw away object-oriented programming, but don't use it for transformations.
All right, cool. Maybe I want to change gears a bit because we talked about some sources of conflict between data engineers and data scientists. But you also made some general observations when we were prepping. That's right. But I call it general observations, but let's say opinionated viewpoints. And you are quite opinionated about documentation.
Yes.
And the previous speaker here just said like how important it is to have documentation. So I'm curious what your take is on documentation.
Okay, so let me start with this. You just bought an oven, okay? Yeah. So now you need to use it. Which oven would you like to have? The one you can intuitively figure out what's going on, or the one which has documentation like this you need to read in order to be able to cook something.
Yeah, I'm an Apple fanboy, so I never read documentation.
Exactly. So when we are users, of course, nobody wants oven which, despite reading documentation, you can't figure out, or there's no documentation and you still can't figure it out. Nobody wants that kind of oven, okay? But nobody also wants an oven that you have to spend hours reading documentation in order to be able to do. Yet, when people write codes, like one of the biggest advice, write documentation, okay? And if you try Googling how to write documentation, 90% of advice out there is nonsense, okay? Yeah. It's so bad. Even like, I don't know how much you use Gemini. Like I asked Gemini to write me some codes. So much useful comment in that, you know? Like I'm just like, try ChatGPT much better. They don't have so much useless comments in them. But the thing is, people write so much useless comments in their codes, and they think this is going to make it better. It's not, okay? Mm-hmm. So for me, as controversial as it sounds, first rule of writing comments is do not write comments, okay? This should be your step number one, okay? First thing you need to do, especially don't write comments like, this function takes an argument, this, and that, and it's going to spit out arguments which are this, and that. It's like, I see which arguments this function, I don't need to see that. And then people are going to be like, but what's the problem? Well, the problem is you're wasting time. You know, we're on the schedule. You're making yourself less efficient. Second, you're making all this noise to my code that, you know, instead of having function on one screen, I have it on 3 screens and I need to scroll to see what's going on. So you're making it actually less understandable. And finally, in the future, somebody will change that function and they will not change the comment. And you're going to introduce confusion, you know? So if it's not useful, just delete it, okay? It shouldn't be there. Unlike unit tests, which I would think twice before I delete some, which I think are not useful, this I would delete. I see a problem with that. Like, just delete useless comment. And now that you deleted useless comment, first thing, focus on your logic, okay? See if you can simplify the logic. There's always a way to make things more logically simple, so it's kind of easier. Of course, you need to make spaces, all the indents, you know, just make it look nice so that looks. Second, very important, make meaningful names of the functions, you know, but really meaningful. Like, don't say filter energy, okay? I see this function is filter energy because the code of the function, hello PySpark, it's filter energy larger than this, okay? So I understand this is filtering energy. What I don't understand is like, why am I filtering this energy, okay? So this should be in the name of your function, you know? So say, filter unrealistically large energies, okay? So now this is telling me something about this function. You can put what are the types of your variables in the definition of the function, so then you don't have to. So if this taking data frame or string or whatever, this all can be in definition of your function. Make variables which have reasonable names, which is going to inform you. All of that can be done. And only when you exhausted all of this, you can write a comment. But only then. And then the comments which you should write, first, the most important one is the comment which is actually, you know, business knowledge or some kind of knowledge which is just not. For example, in my filtering the energy function, why is this threshold taken? You know, why 1000, not 2000? What does this mean? This we need to comment in the function because person needs to know where is this number coming from. So put a comment, this is coming from this or that, and there is a link or a person or whatever. This is coming outside. And the second thing is, if sometimes, despite your biggest effort, you just can't simplify the logic, okay? And it's going to be too long, and even that you have give meaningful name of the function, some information will be missing because you don't want to have a name of the function which goes off 2 lines, you know? Put this kind of things in there. Weird side cases, you know? Like sometimes you have some weird side cases and the basic logic will just not work. Document that, you know, like this is something which happened.
Okay, all right. Links to something what you just said about sometimes you have weird edge cases and then you need to document it, but ideally you want to keep things simple, right? And there's this quote which apparently is attributed to Einstein, which says, "Make things as simple as possible, but not simpler."
Yeah.
How does this apply to your day-to-day job?
Yeah. So there is everybody says this: keep things simple. Keep it as simple, stupid.
Yes,
yeah?
exactly.
And you hear it all the time, and everybody says, but nobody does it. Okay, well, not nobody, but a lot of people don't do it. Okay,
How do they not do it?
so you constantly run into this super over-engineered code, with overly complicated solutions, and what's going to happen with that? Especially if you're a consultant. You do this, you leave it to the client. Next month, the client is calling you, there is a problem and nobody can figure out how to fix it, okay?
Yeah.
So, this might give you a little bit of more job, but this person is not hiring you again to do anything again. So, if you have over-engineered code, you're making something which is very difficult to understand, very difficult to maintain, and very difficult to upgrade.
Mm-hmm.
And we were talking, like most of our things, they need to work for days and weeks and years, If you start with something super complicated, it's going to die. Sooner or later, this is just going to die, okay? And a lot of people think, oh, I'm so smart if I, make this super complicated architecture that nobody understands. No, you're not so smart, okay? It's actually way more complicated to write simple code than to write complicated code, okay? It takes longer. It looks much. I was talking once to somebody, and the thing were just not working. So I insisted on just making solutions simpler and simpler. I was like, okay, this is not working. Like, just make it more simple. And at the end, we solved it with very simple solution. And he was like, oh, I worked on a month on this, and I produced this much code. It's like, yeah, this is difficult. Making this much code. That's easy, Like when you see the code and it looks easy to write, it probably took forever to come up with this simple solution. So if you want to be smart, make simple solutions. That's more difficult to produce, but also it's going to be more understandable, easier to maintain, and people are just going to like it more.
Yeah, but not simpler, right? That's the second part of the quote. So how do you... maybe a difficult question, but how do you accept when things are complex because that's just the nature of the thing?
It's a complicated thing to know, but it's like most of the times you can make it simpler. Like even if you can't, I would consider this a failure. Like if I produce something and I give it to the person who needs to maintain it after or work on different part of code with me, and they can't understand what I'm doing, and I have to constantly come back to help them, even if that code works, I would not call this success.
But that's a critical point you mentioned it, because complexity is also in the eye of the beholder.
Yeah.
And you're absolutely right. It really depends on who needs to run and maintain your code after you.
Yeah.
Right. And I think sometimes engineers don't have enough feeling for that, and they design something that only like someone with 20 years of experience in super complex cloud technologies can run, which might be true, and it might be the most cost-efficient, fastest, greatest solution ever. But if then nobody in the organization can maintain it, that's not the case anymore.
But you see, like, there is some kind of underlying tone in what you just said, is like that the person maintaining your code is just not as smart, Like you're saying, like, oh, only person who had this experience. No, like, you should not think about like, hey, if they can't maintain my code, they're not smart. If other people can't maintain your code, you are not the smart one. People who have a lot of experience, and know a lot of technology, they can make code which people with much less experience can maintain. It's not...
But then what you say, don't use advanced cloud components because like 90% of people don't know them?
No, that doesn't mean that. Like, advanced cloud components can be simpler if they're the simpler solution, and you can easily explain it to somebody who might not know it, but you can easily explain how to use it. That's fine.
Yeah.
It doesn't mean limit the amount of things you're using. No, sometimes it means expand the amount of things they're using, because the more tools you have, it's easier for you to find the tool which is going to be the simplest for this case. But if you have to use 25 different tools, and put them in this super, like there's like this tool we have, like every time somebody tried to explain to me, I just switch off, like I see this graph and I switch off and I just don't listen anymore. It's not about using this one advanced tool. Actually, that can be a much simpler solution. It's about having 5 million different tools which are paired in a super complicated way, and that's complex solution, And actually, sometimes the newest, the most advanced tool just showed up and you're the only one to know it, but that one is going to be everything so much simple. So if you are smart, if you follow the technology, if you know a lot of technology, you're going to be able to make simpler solutions.
Yeah. Does it also apply to data scientists? And how?
Does it apply to data scientists? For sure. Yes, especially when they need to explain things for business, like you have this kind of 5 million different tools. I'm going to use this test and that test and blah, blah. And the more tests you know, and the better you understand the statistics and what's going on behind there and what different tools, you're going to be able to make a more appropriate model.
Mm-hmm. Mm-hmm.
And you're also going to be able to explain this model better. So this is like, I usually, like when I teach people how to give good talks, I usually use the quote, like make things simpler, but not simpler than that. And this kind of applies also here because, like, for example, when you want to explain something to people who might not experts, and when I say not experts, everybody who is not you is not an expert in what you're talking about. So you need to try to think how to explain it to them. And people think like, especially like when I was, still in physics, like, I'm just going to put so many formulas and people are going to be so impressed with what I'm saying. No, nobody's impressed with that. Like people are impressed with you when they understand what are you talking about,
Mm-hmm.
So, and that comes to writing the code, and writing a code is a bit like writing a book,
Mm-hmm.
It's just like, or a news article, young people think, if I'm going so many metaphors and that's going, and no, nobody's going to read that. Okay. Actually, the very good writers, they manage to express themselves in a beautiful but simple way, something which is keep you engaging and wants to read, and it's easy to understand. You don't want to sit and read 5 times each sentence to understand what's going on. That's the same with the code. That's the same with explaining things to business. Just keep things as simpler as possible, but not simpler than that, because sometimes there are things you just need to do, like I need, if my business needs to understand, what is, what exactly, how does exactly XGBoost work, I will do my best to explain to them to the point they need to understand, but most of the times they really don't need to understand what's going on there, so I can just skip it, like this is not important. This is not something to bother people with.
All right. What is something that each side, when we talk about data scientists and engineers, what is something that each side needs to hear? What is something that you want to tell data scientists, and what is something you want to tell data engineers about this collaboration?
So for data scientists, basically you need to learn what are the best practices. Like all these best practices from software engineering, they are made for a reason, okay? And you need to learn them, to learn the reasons why they're made, and to learn how to properly apply them, okay? Only then they're going to work. And second thing, you need to get interested in production, okay? You can make the best model in the world. If nobody can put it in production, it's useless, okay? So learn what does it mean putting in production, and make sure your model is prepared to easily be put in production. For data engineers, it's like teach, don't preach, okay? Data engineers often come and it's like, these data scientists, they don't know anything, whatever. No, it's your job to teach them. And by that, explain why they need to do this, and again, how properly to do it. Don't like tell them, write unit tests. Tell them this is how you write unit tests and this is why, and also get into data. Like if you want to help data scientists do their models, you need to understand what they're doing.
Yeah, absolutely. So if I'm a data leader and I see the kind of, let's say, behaviors that you just described of like, oh, I see a wall between my data scientists and data engineers, how can I, as a data leader, bring those two camps closer together?
Literally just let them walk in each other's shoes, So if I can, like if it's feasible, just make data engineers, they don't have to do machine learning or whatever, but just use cases, just transformation of the data. Make everybody who's going to design platform, make that person use it, then you're going to feel the pain. If they feel the pain, then you understand what you need to design. And the other way around, make data scientists put their own code in production. And once they do that, they're going to understand what's going on, and then they're going to prepare. But at the end of the day, there should not be data scientists and data engineers. And what we do in my client, all of us does our own data engineering. So everybody does everything, and kind of on the more data engineering front, we have people who will kind of make these templates for us to just kind of make a lot of things magically happen when we do, but we do it all ourselves. So it's, if everybody has a little bit of data engineer and data scientists in them, it's very difficult to put a wall.
Wouldn't you say, like, okay, if I'm a data scientist and I have to do my own data engineering, it slows me down, it's not efficient for me, my value comes from designing new models?
Yes. So how do we do this is basically we have templates. Okay. So when I start a new project, I just open this template. This template already has all the CI/CD, all the asset bundles, all the things for which was naturally in production. The only thing I, as a data scientist, need to do is put my code there. And then with one command, this is in production. Okay?
Make it as simple as possible.
So it's as simple as possible. So everything is already there. Data engineers are the one who are designing these templates, adding functionality to it, helping data scientists do this themselves. But it should be easy for data scientists. It should not be a lot of their work to do this. They should have everything already built in so they can do this easily.
All right. Final question, which I ask all my guests, is what is something that you know now that you didn't know when you started in data?
So my situation is like I kind of came from academia to industry. And I think the most important thing I learned is like technical skills, that's good, but soft skills is what is going to make it or break it for you. When I talk to some of my friends from academia who maybe tried industry and went back, usually the reasons for them coming back are first, data is so dirty, it was impossible to do anything there. And second was like, business kept asking me to do things which are impossible and not listening to me and then blaming me for not being able to do it. Okay. And what I want to tell them and what I luckily learned when I started working is like, it's your job to make business understand. Because unlike in academia, you are, your boss is going to be expert in what you do. And it's going to be easy for you to kind of explain this kind of things. But in business, no, they're not experts in what to do. And it's your job to learn how to communicate with them and how to explain what is possible, what is not possible, and to kind of keep them happy in this process. Because at the end of the day, they just want a certain thing done. And how that's going to be done, it's your job to figure out and also explain to them. And on the other side, data is dirty. But it's your job, again, to deal with this dirty data and still get some insight out of it. And it's also your job to make sure the whole atmosphere of happens, that there is the thing. I was super annoyed that I don't have the access to production data and I could just complain, or I could make sure that people who need to know about this, present them these problems, and finally I got what I needed at the end. So people can't magically do stuff for you because, you need to work for it.
I think those are very, very wise lessons or wise words to conclude. Jelena, thank you very much for being on the podcast, and best of luck at your client.
Thank you.